Hey guys, welcome back. My name is Miss Danielson, and today I'm taking you through a lesson on cube numbers. I hope you joined us for our previous lesson on square numbers and square roots, because those lessons will help you to understand this one. So I'm linking them down in the description box below. Feel free to check those out and come back when you're ready. Let's get started. Cube numbers are the result of multiplying a value by itself 3 times. As you can see, we show that by putting a little 3 up at the top. That little number up at the top is called a power or an index or an exponent. So if we say 3 cubed, it's the same thing as 3 with a power of 3, or 3 with an index of 3, or 3 with an exponent of 3. So what I want you to do is work out these cube numbers from 1 cubed up to 9 cubed. Now I wouldn't ask you to memorize them, but if you have a really good memory, it might come in handy. I'll be honest with you, I know my cube numbers up to about 5. And for the other ones, I generally go through my mental calculations to work them out. So don't worry about memorizing them. Just take your time and multiply them out now. Go ahead and hit pause and hit play when you're ready. Okay, I hope you've hit pause. Here they come. Those ones I know. Here's where I get iffy too. Now I bet you wish I gave you one more to work out, because that one everyone can work out. Where's 10 cubed? That's an easy one. In fact, 10 with any power is fairly easy to work out. We call these our base 10 numbers because the bottom number is 10. 10 as a base with an index of 1 means just 10. We don't need to multiply it by another 10, we just want one 10. Whereas 10 to the power of 2, or 10 squared, is 10 times 10. That is 2 10s being multiplied together. 10 to the power of 3, we call this one 10 cubed, and clearly it's 3 10s being multiplied together, and so on. We can easily multiply by 10s because all that does is shift the place value up 1. 10 to the power of 1 is just 10. 10 to the power of 2 is 100. 10 to the power of 3 is 1,000, and 10 to the power of 4 is 10,000. Notice something interesting that makes this really easy. The power always matches the number of zeros. But this is only when you have 10 as your base value. To explain cubing geometrically, remember how we explained squaring geometrically? We talked about squaring a value as being the same as the number of squared units that would fit inside the area of a square with a given side length. So in this example here, my square, which is 5 centimeters by 5 centimeters, has an area of 25 centimeters squared. Similarly, we can talk about cubing as being the number of cubed units that would fit inside the volume of a cube with a given side length. So in this example here, I can fit 3 cubes by 3 cubes by 3 cubes inside a cube with dimensions 3 centimeters by 3 centimeters by 3 centimeters, and the number of centimeter cubes that fit inside the volume of this 3 by 3 by 3 cubed is 3 cubed. That's 27 centimeter cubes. Much like square rooting, when we're cube rooting, we're asking where do these cube numbers come from? And like with square rooting, I suggested maybe they grew on a tree. So maybe cube numbers grow on a cube tree. And if that's the case, they must have come from their cube roots. Cube rooting is the act of finding which value was multiplied by itself 3 times to give a cube number. You should already be familiar with what cubing a value means. It means multiplying that value by itself 3 times. You worked out these cube numbers so that you could recognize them if you saw them again. So let's try and put what we know about cube numbers into practice here. Which value was multiplied by itself 3 times to give this cube number? 3 times 3 times 3 makes 27. So if 27 is the same thing as 3 cubed, that must mean that the cube root of 27 is 3. Now be very careful because a very common mistake is that people think 27 is 3 cubed, therefore the cube root of 27 is 3 cubed. That's not the case. Cubing and cube rooting are opposite operations. So when I've gotten rid of this cube on the 3, it's gone over to the other side and it's become a cube root. The opposite operation of cube is cube root of 27. We don't have a cube on the right-hand side at the same time as we have the cube root on the left-hand side. It's moved. Next, is there a second possible cube root value? Because remember with square roots, we always said that there were two possible square root values, the positive and the negative. So does that mean that the cube root of 27 is either 3 or negative 3? Let's think about when we cubed negative numbers now. When you multiply a negative number by a negative number, like negative 2 times negative 2, we get a positive result. But then we take that positive result, so positive 4, and we multiply it by a negative number again, and we get a negative answer. A negative value cubed will stay negative. We can translate that backwards to say that a negative number cubed rooted would give a negative value, or a positive number cube rooted would always be a positive value. So no, there is no second possible cube root value. When you cube root a number, there is only one solution. If you cube root a positive number, that solution will be positive. Let's try another one. So 64. What's the cube root of 64? What value was multiplied by itself 3 times to give this number? If you don't have your cube numbers memorized, just think of the ones you know. For example, we just did 3 cubed, which was 27. Do you know any other cube numbers higher than 3 cubed? If not, just go trying. What about 4 cubed? 4 times 4, 16 times 4 is 64. So if 64 is the same thing as 4 cubed, then the cube root of 64 must be 4. Just 4, not positive and negative 4. That's only for square rooting. If you're going to use your calculator to check your answers, and I don't want you using your calculator otherwise, I want to make sure that you're not going to confuse the square root sign and the cube root sign. This is the type of calculator we generally have at our school, and this is the square root sign. It is not the same thing as the cube root sign, and don't make the mistake of thinking I just put 3 and then this symbol and then our number. This is your square root sign. You need to be familiar with your calculator, but on our calculators, we find the cube root function just above the square root button. So if you've got this printed on the calculator rather than on the button, what you're going to need to do is first push the shift button, that's this one here, let it go, you don't need to hold it down, and then push this square root button. That should allow you to cube root the value you enter after that. If you're not familiar with your calculator, I suggest you get familiar with your calculator and always try it out with numbers that you know the answer to. We know that the square root of 9 is 3. So try using your square root button, do square root of 9 and see if you get the answer 3. You should also know that the cube root of 8 is 2. So use your calculator, and if you've got the same calculator as I've got, push Shift, the square root button, and 8, and work out your answer. It should be 2. If you don't have the right answer, you're not correctly using your calculator. Send me a message down below, and maybe you can send me a picture of your calculator and I can tell you where the buttons are. Time for some practice now. For question 1, I want you to figure out how many 1 centimeter by 1 centimeter by 1 centimeter cubes it would take to make cubes with the following side lengths. Remember, cubes have the same length, width, and height, so their volumes would be the same as this number multiplied by itself repeatedly 3 times, or this number cubed. For question 2, I want you to work out the side lengths of cubes with the following volumes. So this is the opposite. You need to find that the length, width, and height, which are all the same number, which multiply together to give this volume. So cube root. For question 3, without a calculator, try to work out the cubes of the following number. Now 15 cubed would be quite big. 0.4 cubed and 1.2 cubed, these are decimal numbers. It might be easier to work with fractions. Question 4, I want you to work out the cube roots of these numbers without a calculator again. And 64,000 is quite a high number. Maybe you want to break it down. 0.125 is a decimal number. You'll want to make that a fraction first. And question C, 1,728, is quite big. Again, maybe you want to break that down. Go ahead and hit pause now, copy the questions, work out your answers, and push play when you're ready to take them up. I hope you've had a chance to hit pause, because here come your answers. For question 1, remember we are cubing these lengths. For question 2, we are cube rooting these volumes. For question 3, without a calculator, I can do 15 cubed by doing 15 times 15 times 15. Or I could say that 15 is the same thing as 5 times 3. So 15 cubed is the same thing as 5 times 3 in brackets cubed, which would mean that 5 is cubed and the 3 is cubed. And I do know what 5 cubed and what 3 cubed is. That would be 125 times 27. This gives us one long multiplication to work out rather than two of them. Either way, our answer is 3,375. For question B, as I warned you, with decimal values, it's generally best to work them out as fractions first. So 4 to the power 3 over 10 to the power 3. I know what 4 cubed is. I know what 10 cubed is. That's going to be 64 over 1,000, which is 64 thousandths. And 1.2, that as a fraction could be 12 over 10. So 12 cubed over 10 cubed. If you had trouble working out what 12 cubed is, 12 is the same as 3 times 4, so 3 cubed times 4 cubed. Well, 10 cubed should be easy for us. 3 cubed is 27, 4 cubed is 64. However you worked it out, you should have the answer of 1.728. Question 4, which was a bit more challenging, 64,000, I hope you thought of as 64 times 1,000. So the cube root of 64,000 is the same thing as the cube root of 64 times the cube root of 1,000. Cube root of 64, you should recognize by now, is 4, and the cube root of 1,000, of course, is 10. So 64,000 cube rooted would be 40. 0.125 as a fraction would be 125 thousandths. So we're doing the cube root of 125 over 1,000. That's the cube root of 125 over the cube root of 1,000. Now the cube root of 1,000 should be easy. The cube root of 125 is 5. So that's 5 over 10, 5 tenths, or 0.5, a half. 1,728 is quite a large number to be cube rooting, and I don't recognize it easily to be the product of two cube numbers, like in question A. So I recommend that you break this down into prime factors. If you haven't tried it yet, hit pause and try making a factor tree to see what the prime factors of 1,728 are. 1,728 divides by 2, and the answer is 864. 864 is not prime, it still divides by 2, and the answer is 432. Still, 432 is not prime, it divides by 2, and the answer is 216, which could still divide by 2, and the answer is 108, which could still divide by 2, and the answer is 54, which can still divide by 2, and the answer is 27. I've come to an odd number now, but it's not prime. 27 can still divide by 3, and the answer is 9. 9 is not prime either, it also divides by 3, and the answer finally is a prime number, 3. Now looking at all of these circled prime numbers in green here, I've got 1, 2, 3, 4, 5, 6 2's and 3 3's. And remember, we're trying to cube root this number 1,728. That means work out what number was multiplied by itself 3 times to make 1,728. Let me color code this for you so you can see it clearly. 2 2's and a 3. 2 2's and a 3. 2 2's, and a 3. 1,728 is the same thing as 2 to the power of 6 times 3 cubed, which could also be grouped evenly into 3 groups, each of those groups being 2 squared times 3. So the cube root of 1,728 is the same as the cube root of 2 squared times 3 cubed. Those are opposite operations. We can cancel out the cube at the same time as we cancel out the cube root. That's going to be 2 squared times 3. Now 2 squared we know is 4, so that's 4 times 3. So our answer is 12. The cube root of 1,728 is 12. If you don't believe me, try doing 12 cubed. You should get 1,728. Now this question C was a really advanced level question, but it's really interesting to see how you can break any number down into its prime factors to see what it's made of, and then from there work out what it could be divided by. I hope you found this lesson interesting, and if there's any doubts, please let me know in the comment section so I can help clarify them for you, or maybe you just want a few more examples. Please let me know if another exercise on this would be helpful. Until next time, keep practicing, and I hope to see you soon. Bye.